For people who are blind or lack fine control of their fingers, touchscreen interfaces such as those used on self-serve kiosks can be virtually impossible to operate. The experimental new BrushLens device, however, utilizes the user's smartphone to get the job done. Currently in functional prototype form, BrushLens is being developed at the University of Michigan by a team led by Assistant Professor Anong Gui and Associate Professor Alanson Sample. Essentially a high-tech smartphone case, it leaves the phone's screen visible and accessible on top, and has a window for the phone's rear-facing camera to peek through on the bottom. A ring of auto clickers, which alter the capacitance of a touchscreen to simulate a finger touch, surround that window. As a BrushLens-equipped phone is moved across the surface of a large touchscreen, the phone is able to read the displayed text via its camera. An accompanying app speaks out the words as the phone passes over them. When the user wishes to click on any of the displayed words, they can either tap a large easy-to-hit button on their phone's app screen, or utilize the phone's existing screen reader function, in which selections can be made via simple swipes or other gestures. Once the system is developed further, the user could also simply speak a verbal command. Whichever the case, the BrushLens responds by activating the relevant auto-clicker, causing a touch to be registered on that part of the underlying touchscreen. Additionally, once the layout of the display on that screen has been mapped, the app can verbally guide the user across it. It does so by dividing the screen into a grid, and using the phone's inertial measurement unit to track the phone's position within that grid. By comparing the grid location of the desired on-screen button with the current grid location of the phone, the app is able to tell the user which way to move their phone, right up until it reaches that button. The technology has been tested on 10 volunteers, 4 of whom were afflicted with tremors or spasms, and 6 of whom were visually impaired. In all cases, after an initial learning curve, the device improved their ability to use touchscreen displays. The prototype cost less than $50 to make, and a refined commercial version should be considerably less. Among other cost and size-cutting measures, the final version could be powered by the phone's battery, and it could use the phone to perform all of the data processing.